So no one had really made these measurements in urban ecosystems. Everybody was measuring agricultural systems. So we started making measurements here in Irvine on how much N2O was coming out of Irvine soils. And this is Amy Townsend Small, who was a postdoctoral researcher. Now she is leaving to go to the University of Cincinnati as a faculty member. And she made measurements of nitrous oxide all over the place. What happens is the emissions of N2O are low most of the time, but as soon as you fertilize, a big pulse of N2O comes out for a few days. And you got to make these measurements frequently and capture all these pulses, and then you can add them all up and get how much N2O comes out over time. Turns out that nitrous oxide emissions, they increase with fertilizer application, but they also increase with irrigation. So there's a lot of scatter here, but this is a relationship between nitrous oxide fluxes and soil moisture. This is a student in my lab, Nita Bajor, made these measurements. So as you irrigate more N2O comes out, and that is because denitrification is an anaerobic process. The microbes that denitrify, they need conditions of low oxygen in the soil. And when the soil is full of water, oxygen can't penetrate. Oxygen diffuses very slowly in water. So we have now more N2O emissions with fertilization, more N2O emissions with irrigation. And now, this was a very controversial paper, I have to say. Amy and her colleague Claudia Green published this paper, and there was a lot of furor in the press over this because the lawn care companies were kind of upset about this paper. Now, I didn't know this, but the lawn care companies have really been banking on the ability of lawns to store carbon for some reason. They thought that was going to be a big growth area for them. So they have been telling people, I guess, that lawns are good because they store carbon in the soil. So Claudia and Amy, they did some calculations of this. They went to 4 parks in Irvine, and the city of Irvine was actually very helpful, gave us permission to work in 4 parks of different ages. So some parks in Irvine were established when Irvine was established in the 70s, and some are newer. So they went to these parks and they measured 2 kinds of lawns, the picnic areas and the athletic fields. The athletic fields get torn up all the time. They have to replace the turf in the athletic fields frequently because people, run around on them. Well, those athletic fields, they don't store carbon in the soil because the soils are always being turned over. So what you see here is the global warming potential of either the carbon in the soil or the nitrous oxide in the soil. So the global warming potential means that if you're storing carbon, you're removing CO2 from the atmosphere, you have a cooling effect, and that's a negative global warming potential. If you emit nitrous oxide, global warming gas, you have a positive global warming potential, a warming effect on the atmosphere. So athletic fields, they don't accumulate soil carbon, but picnic areas do, and your lawn probably does at home. If you don't replace the turf all of the time, if you just leave it, let it grow, a lot of carbon accumulates in there. It's true. It's actually a remarkable amount of carbon from an ecological perspective. But these lawns are also emitting nitrous oxide because they're fertilized. And if you start taking other things into account, like how much fuel is used for mowing and blowing and all of those things, and how much energy is used for irrigation. It turns out irrigation costs a lot of energy. And how much energy it takes to make inorganic fertilizer, which is a hugely energy-intensive process, then you end up with a lot of global warming potential from these lawns. So these lawns are either warming the atmosphere on a net basis, or this one is actually just carbon neutral, warming neutral. And if you can Google this paper and you'll see all kinds of buzz about this in the press. So